This is Joe Kennedy here with my colleague David Browne. Between David and myself, we've many years, many grey-haired years of dealing with various aspects of off-street manufacture, from a simple concept just as windows arriving to site to entire buildings. So this is a broad overview of the subject. It's a very multifaceted subject, and to date, I don't think it's received the sort of broad and integrated conversation that it requires if it's going to become a standard solution to procuring buildings. And maybe this discussion this morning will help move towards that point. We have a number of slides that deal with an overview of what's happening at present, some of the problems and issues that we think need to be discussed, how COVID-19 might be addressed in that context, and a case study. We're not going to talk through every point that's on every slide. Obviously, you'll be here all day, but you'll be getting all the slides later anyway. So I'm going to hand over to David now. David?
David, are you with us? Have we lost David?
Hello, can you hear me?
Yeah.
Yes, David.
Good, okay. So I'm going to give you an overview of off-site manufacturing in Ireland. So off-site manufacturing is now developing at scale in the UK and the US, and it's facilitated by the increased use of BIM, and it's helping with the speed of delivery, particularly, I would say, in the housing sector. OSM did emerge to some extent in the Celtic Tiger years. There were some very notable developments, and then it fell back. And it has been re-emerging in both the Republic of Ireland and Northern Ireland over the past few years, but it's still not at any great scale. And consequently, OSM in Ireland is typically component related, with little modular, except for some M&E construction. And as Joe mentioned, it's not without its problems and concerns. Okay, next slide. So one of the big issues in relation to particularly modular is the finance model, because traditional construction payment is made for completed work on site or vested materials. But with OSM, the model is different. You need upfront investment to manufacture the product. You need R&D to certify the systems before they're manufactured and accepted in different markets. You need earlier payment before OSM units are delivered, which is quite a difference compared to the traditional system we work on. There are higher pre-planning and design costs and front-loaded payment risks for the client. And critically, the module supplier, the manufacturer, now becomes a big part of the supply chain and is critical for the delivery of projects on time. So we need to look at mitigating risk with early supply chain involvement, and that, I believe, is critical from talking to colleagues in the UK, that you need to be speaking with the manufacturers from the get-go, and you need a lot of collaboration and proper risk apportionment. Okay. So in terms of quality, there's certainly potential for higher finished construction quality, but there are risks, and I think these need to be ensured. There's durability and maintenance. One of the classic ones with timber frame constructed houses was the vulnerability of the moisture membrane, which on site was very susceptible to breaking and therefore long-term issues. So there's a big need for warranties, and there is a model in the UK, the Build Offsite Property Assurance Scheme, which might be emulated here. The other important thing is that new inspection protocols for third parties, the architects and engineers, need to be developed so that they can be related to offsite manufacture. Okay, next. So in terms of, one of the really big issues is that early design decisions are critical. Traditionally, a design is produced, planning permission is obtained, detailed design begins, and then value engineering starts. That can't happen now. You need to get in and do your value engineering right at the start of the project, so that by the time you're going to planning, you have a real vision of the finished product. And that will need new design management approaches. You can't carry out change management after manufacture commences. The consequences are just too big. So you will need experienced project planners, experienced designers, and manufacturers who know what they're doing. So potential advantages of off-site manufacturing. Well, obviously you now are building in a controlled manufacturing environment. So you have the potential to have much improved quality. You've better conditions for the workforce, better efficiency, and better health and safety. And then in terms of speed, you can complete the modules in parallel or even before early construction. You will achieve faster on-site erection, up to 60% in some cases. There's less on-site work for construction personnel, which has its pluses and minuses, as Joe will talk about. And OSM can be efficient for city centre sites because of the speed and the ease of craneage. You can get big reductions in construction waste. You can get reduced snagging. And then the early decisions, if carried out in a disciplined way, will reduce, hopefully, the potential for on-site delays and cost overruns.
Okay, Joe, back here now. Let's look and maybe discuss some of the problems and the issues and the concerns that really do need to be explored. David mentioned the greater risk for the client due to earlier payments. I mean, there are things that can be put in place to protect the client, but it's still a risk, even with prepayment bonds and risk sharing. All the decisions are front-loaded. That can bring some significant problems in an evolving brief, particularly in things like healthcare, where technology changes every year almost. And with long procurement processes, where the procurement starts, but the project isn't delivered for several years, such as in schools, these front-loaded decisions are sometimes not that easy to get nailed down. And then some of us have concerns about the standardization that comes from BIM and other ways of procuring design, especially if we're designing for established ways of delivering modular construction, where there's a move away from bespoke solutions. That has a lot of advantages, moving away from bespoke solutions, but it also will restrict, if we're not careful, the innovation in design that has led to our buildings in cities evolving over many years and changing with the times. So that commoditization of building requires responses in design that will protect the design quality, especially in urban areas. And then there's the local employment impact that David alluded to. I've spent some time in Kenya in the last few years, and it's noticeable over there, where the Chinese are doing a huge amount of construction, that they bring everything with them. They bring modular construction, they bring their own staff, their own workers, and there is very little positive impact on the local economies. There is very little local employment. That's a significant concern in developing countries that we should be aware of, and there need to be facilities put in place to try and address that. One company we've worked with in the past, a UK company, Chapman Tracy, they had systems where they used to build a factory on site and then employ local people to do the prefabrication. So it was just barely off-site manufacturing as against full off-site manufacturing. Specialized versus general skill sets. Lower skilled workers are less likely to be required in OSM. And then quality. Errors that are made in the off-site manufacture are embedded forever in the project if they're not caught at the pre-erection stage. Now, I know that we can have very strong quality control measures to try and stop that, but it's something we should be aware of. And sometimes errors can't be spotted early because evolving knowledge of things like, say, pyrite. I know pyrite isn't relevant in itself, but something that evolves as a problem later can get fully embedded in a project. And also repairs can be more problematic to address. Say, for instance, a bathroom pod comes in from China and 3 years later, there are problems with the plumbing. How do you fix that? You can't go back to China to get the fix, and nobody in the vicinity has done any of the work. So there are issues that need to be looked at. Obviously, there are contractual issues, and I'm sure they can all be dealt with, but they need to cover things like who owns the goods prior to delivery, who bears the risk of damage during storage, and how is completion liability in particular dealt with. And then this BCAR and regulatory. We won't really know until the first case goes through the courts, which is inevitable under BCAR. We won't know what liability is attached to inspectors and certifiers in relation to the OSM. The BCAR system is a blunt and a very onerous system, as we all know. It has advantages and disadvantages, but how we adapt the code of practice to deal with inspection and certification off-site needs to be thought through in conjunction with the department. I don't think the current code can be adapted properly to cover the inspection risks and the protocols for OSM. And then finally, the coronavirus. Will it lead to permanent changes in building? To some extent, I think it will. I think there will be a move away from having close quarters work that isn't necessary. So that might mean making our modules larger than they are at present, like our unitized window systems. The 2 meter distance isn't going to last forever, probably not even through the summer. So that's not going to be a permanent protocol, but I think there will be a change in trying to reduce people working really closely together. And OSM certainly has a role to play there, but it does transfer the risk for infection in future pandemics, possibly away from the building site and into the factories. Back to you, David.
Okay, thanks, Joe. So how does BIM support OSM? Well, I think BIM and the 3D model that comes out of it does give greater precision in specifying material requirements. So it may help with reducing over-ordering and will help, I think, in decreasing construction site waste. I think it's particularly important in helping fabricators and contractors with 3D models of element positions so that you can accurately represent the geometry, hopefully the behavior and the properties of the different components that go into the various modules. I think it can help facilitate putting those components into the standardized building elements or volumes. And then it also allows much more direct interfacing and collaboration between the designers, the suppliers, the manufacturers, and the users. And I think it can help avoid lead-in times, high costs, and modification problems. Although one sort of consequence of working with OSM and BIM is that I think it will put a lot more pressure on the designers at the front stage, because so much of the process is front-loaded. And therefore the incorporation of standardization will I think greatly assist in having BIM support OSM. So I have a number of examples and then a case study to take you through. And I think these are kind of representative of what the state of play is in the market here in Ireland at the moment. So here's some typical examples. So Dublin Landings and Capital Dock, which are recently completed commercial projects, they both incorporated brickwork on precast concrete panels. And I mean, if you take both of those buildings, look like they're brick-clad buildings, but in fact they're based on a precast system. I think everyone is familiar with unitized cladding and glazing facades. This is one going up at the moment on Shelburne Road in Dublin. And interestingly, this and the next project were both assembled in Ireland, which is a sort of a step forward. Again, both these projects were built on 1.5 meter modules, but I'd be promoting moving to 3 meter if that were possible. This other one is 76 Sir John Rogerson's Quay. Joe?
There are many, and there have been many types of OSM, and some of them have failed to catch on. This is one that failed. My colleague Martin McKenna was involved in this school design, we used a system called Eurozone, which was effectively prefabricated, insulated shuttering that was with concrete poured on site. It was a very good system because it allowed for flexibility if things needed to change on site with in response to maybe client requirements, etc. But the company eventually wound up because they couldn't get standardization of their codes and of their systems accepted throughout a large market in Europe. This is a volumetric prefabrication example in the UK, where all of the hotel bedrooms were completely built off-site, completely fitted out, carpeted, pictures hung on the wall or stuck to the wall. Bathrooms and everything was brought to site as a completed module, and the only thing that had to happen on site after the substructures were built was the external cladding and the completion of the roof. It saved about 1 million out of a £16.5 million budget in terms of, mainly in terms of preliminaries being saved. And the standardization of the bedrooms was something that was very suitable for this type of project, where all the bedrooms, I think there was only one other type of bedroom other than the standard one. And another interesting area that you may have come across is the notion of flatbed houses. So IKEA Skanska have come together in Sweden to form a company called Boclock. They've produced already about 11,000 housing units in Northern Europe, Denmark, Sweden, Norway, and Holland, I think. And they now are about to deliver their first set of 160 units in the UK. It's very interesting. They're pitching their product very cheaply, so it's well below the affordable level, and it comes with various levels of finish. You can just get an empty box effectively that you do yourself. So that's an interesting idea. It's an unproven idea, I think, in our regulatory system here, and possibly in our climatic environment as well. These houses are designed for cold, dry climates, and Ireland has a particular problem with this type of construction, and because we've got a very high humid cold climate. So where our dew point, for instance, in our external walls occurs in a different position than it would in Sweden.
Okay, just moving on. So, some recent industrial projects that my company have been involved in. The modular M&E assemblies are proving very effective. This particular large industrial project, we had an electrical installation with battery racks, UPS, and LV cabinets. And as you can see, it's quite a big component of 3 by 12 meters, and 7 or 8 of these go into the particular industrial building. In apartment buildings, these new MVHR pods are becoming quite popular. The photo on the right is in Sir John Rogerson's Quay, which is a standalone purpose-built unit. The other one is one we're developing for Connolly, which is a, you can see that the washer and dryer has been built in, but all of this is assembled off-site and then delivered. Okay, the next one then. I think everyone is familiar with residential bathroom pods at this stage. They've been in the market for the last 20 or so years, and I don't think I need to say much more about them. Here's another interesting hybrid. So, and this one is at design stage for a large-scale industrial project. As you can see, it's a big facade, 35 meters high, and it's a couple of 100 meters in length. But here, we instead of putting in individual cladding panels, the idea is that we will be making up composites of about 15 meters by 8 in size. And then they would be lifted into place using a tracked roof mini crane and a cherry picker. But we've estimated that a 5-man team can get through 400 square meters a day. That would be with on-site construction remote from the actual construction activity. And then just take you quickly through a case study that we did for GE Healthcare at their biopark in Cork. So this was a large, here, as you can see on the bottom right, there are 4 modules within a larger complex of your typical manufacturing area. There's warehousing, offices, laboratories, and a large energy center. And these modules are 1 and 2 story, 3,275 square meter pharmaceutical manufacturing modules. If you go to the next one, and this is what one of the finished versions look like. It's CGMP compliant, and it's designed for scalable and cost-efficient production of pharmaceutical and biopharmaceutical manufacturing. So the modular units are pre-validated along with processing equipment, and then transported to the site where they're assembled. And GE say that you can go from project inception to completion within 14 to 18 months. Interestingly, I'll show you what happened on our project in a sec. If we go to the next one. So what we have the 4 production, they're called cubios. They've a total area of 13,100 square meters. They're broken down into prefabricated units of 4.5 by 9.6 by 4 meters high, based on transportation. They're supplied complete with all interior building finishes and the services installations, and they are prefabricated and pressure and integrity tested off-site at the manufacturer's premises, which is in Germany. Next slide. So interior finishes, composite metal cladding, secret fixed to modules, and then it's designed for connection to a central spine, and the total development was 42,500 square meters. But the timing is interesting. The concept design started in April 2016, and we got through to planning by March 2017. It was tendered during the planning stage over 7 months, from December 2016 to August 2017. And we had a construction program with enabling of 3 months, and then a construction program of 22 months. So a little bit longer, but I think the real gain that the client saw was the quality that they would get in both the finished building and in the service installation that was supplied.